All right, let's dive right in. Have you ever stopped to wonder how you can watch a video that's streaming from a server, halfway across the planet, on a phone made by a totally different company than the server? Today, we're going to crack the code on that invisible magic that makes it all work: computer networks. We're going to break down the one single idea that powers our entire connected world.
So let's just frame the problem for a second. Seriously, think about it. How in the world does a Mac computer sitting in Tokyo running Mac OS send a message to a PC in Toronto that's running Windows? I mean, they have different hardware, different software. They don't speak the same language at all. How is that even possible?
And here's the secret. It's not one single complicated solution. The real genius behind all of this is realizing that instead of trying to solve one gigantic, impossible problem, it's way, way easier to just solve a bunch of little, manageable ones. It's all about breaking it down into bite-sized pieces.
So this really clever strategy of breaking things down, well, it has a name. It's called layering. And honestly, it is the fundamental concept that makes our digital world tick. So let's really unpack what that means.
Okay, so what is layering exactly? It's pretty simple, really. It's the process of taking a huge, messy problem and chopping it up into smaller, much more manageable chunks. You solve each of those little problems one by one, and then you just stack the solutions on top of each other. And just like that, the original massive problem gets solved. It's a simple idea, but wow, it is incredibly powerful.
This visualizes it perfectly. You start with this giant, chaotic mess of a communication problem. Then, that mess gets broken down into very specific, separate tasks. Each one of those little tasks gets handed off to its own layer, and that layer has only one job to do. When you stack all those layers together, they create this clear, organized pathway from total chaos to perfect clarity. The big problem? Solved.
So we get the what, but now it's time for the why. I mean, why is this layered approach so darn effective? What are the actual real-world benefits that make it the gold standard for how we build networks? Let's take a look.
To really see why layering is so great, just look at these two approaches. On the one hand, you could try to build an all-in-one system, just one giant, complex machine. But if one tiny little thing breaks in there, man, good luck finding it in that tangled mess. But with the layered design, everything is modular. The parts are independent. So if something goes wrong, you know exactly which layer to check. It makes finding and fixing problems about 1,000 times easier.
So, let's sum it up. Layering gives us this modular design that's super easy to troubleshoot. It also means each layer can have its own set of rules. We call them protocols that are just for that specific job. Put it all together, and what you get is effective, reliable communication. It just works.
Okay, so we know why we use layering, but how is it actually put into practice? I mean, for everyone's layers to work together, you need some kind of standardized blueprint, right? Well, the first big attempt at creating one was called the OSI model.
The OSI model, that stands for Open System Interconnection, was developed by the International Organization for Standardization, or ISO. And the goal here was huge: create one universal standard for all networks everywhere. The key word they were chasing was interoperability, making absolutely sure that any system, whether it's Windows, Linux, or anything else, could talk to each other without a problem.
But here is the single most important thing you need to remember about the OSI model. It is not a real-world system. It was never actually implemented. You should think of it more like a diagram in a textbook. It's a fantastic theoretical guide for teaching people how networks should be designed, but it's not what we use to actually build them.
So, if the OSI model is just a teaching tool, what does the real internet actually run on? Well, that brings us to the second and much more practical blueprint, the TCP/IP model. This is the one that really matters.
And here's a funny little twist in the story. You'd probably think that the practical model came after the theoretical one, right? Nope, it's actually the other way around. The TCP/IP system was already up and running back in the 1970s, way before the OSI model was even published in 1984. And that little fact explains why the two models don't line up perfectly. They were basically developed in their own separate worlds.
So unlike the OSI model, the TCP/IP model is the real deal. It's a whole suite of protocols. Think of it like a toolkit where every single tool, or layer, has a very specific job. For instance, one layer's job is to just handle the physical address of a machine. Another layer is only worried about which application the data is going to. Each layer does its one job, does it well, and together they make the internet work.
This table really just lays it all out, crystal clear. The OSI model,
It's a theoretical guideline. It came second, and we use it to understand the concepts. The TCP/IP model, that's the practical, real-world implementation. It came first, and it's the actual foundation of the internet. It's pretty simple. One is for the classroom, and the other runs the world.
So at the end of the day, what this all comes down to is that these layers, these models, these protocols, they are the invisible architecture that is literally holding our entire digital world together. Every single email you send, every video you watch, every website you visit, it is all powered by this simple, beautiful idea of solving huge problems by breaking them into small, manageable pieces.
And that leaves us with one last big question. As technology keeps racing forward with things like the Internet of Things, AI, quantum computing, what new communication challenges are we going to face? And maybe more importantly, what new layers are we going to have to invent to solve them? Thanks for joining me for this explainer.